All right, so my name is Glenn Willen. I work as a software engineer in the Bitcoin space, and I work for a company called Blockstream. And I put that text very small on the slide because Blockstream is not, Blockstream is not responsible for the content of my presentation. They have not approved it or even reviewed it. So everything in this presentation is my fault and my fault alone. But I do want to give them credit for supporting my journey in learning about all things Bitcoin and blockchain. So I also want to note that, a bit contra the title, I'm not really going to be naming names for the most part tonight. Wouldn't matter anyway, because if you wait 3 weeks, all the names are going to change. But there's still plenty for us to talk about. Now we find out if I know how to advance my slides. There we go. So you've probably seen this before. This is the Gartner Hype Cycle. And I put it up because my talk is going to have a lot to do with hype. There's a lot of hype in the blockchain space. There's a lot of like, here's this cool thing, let's figure out what we can do with it. Don't really care what it's good for, we're going to figure that out later. And one thing that a lot of people like to do with this chart is overlay it over the price of Bitcoin and go, see, we're at the good part now. We're at the good part now. So we have an aphorism for that. So this tweet, you can tell when I was working on this talk, if you have eagle eyes, you can see that the date on this tweet is actually yesterday. When Vint Cerf is throwing shade at your entire industry, you're maybe in some trouble. So I'm here today to tell you a cautionary tale about blockchains and what they're good for and what they're not good for. And it should be pretty clear from the title that I'm planning to throw a little bit of shade myself, but I hope that you get a lot more out of this than that. My goal is to be educational and also entertaining. And I guess I'll note at this point that I've actually never given one of these before, so I appreciate your forbearance. So first, a little note on terminology. So cryptography for a long time has been abbreviated as crypto. And I'm sure this was much to the chagrin of someone way back in the day, right? But this is now pretty well established. But what we've started to see lately edging in is people referring to cryptocurrency as crypto, much to the chagrin of all the cryptographers who are really, really pissed off about this. And language changes, but like, come on, no, not this one. This one's not allowed. And whatever you do, do not say, please do not say the crypto. No. Cryptos, yes. And so, of course, the same thing is happening to blockchain. So the blockchain, the Bitcoin blockchain, is a data structure. It's a specific thing. There's a lot of copies of it. And what we've started to hear happening as there's more and more projects based on this technology of the blockchain is the language, again, has started to evolve. And you've got people using blockchain as a mass noun for like the whole field. Like, oh, we need some blockchain. We need some blockchain on this project, just a little more blockchain. So I'm going to tell you not to do that either. But I'm also going to do it at least 5 times probably during this talk because it's beyond help, so please forgive me. All right, so we got the important stuff here. Oh, I think I made that a little too dark. So first, I'm going to talk about why my blockchain is awesome, and by my blockchain, I mean Bitcoin, which is the first blockchain, and I'm going to talk about a brief history of some of the cool technology that has gone into kind of Bitcoin and blockchain. So a sort of history of the cryptography that is involved here. Then I'm going to talk about why your blockchain sucks. And by that, I mean, I'm going to go over some use cases that we see for blockchain technology and what's better and what's worse and kind of why. Yeah, so a brief history, and this is not just background. I mean, it is background, but don't tune it out, because in order to answer the question of, is a blockchain good for this? Do we need a blockchain for this, whatever this particular project is? We need to know about kind of, well, what does a blockchain bring to the table, right? Like, what are all the pieces here? Which ones are useful, and which ones do we not really need? We need to know sort of what advances does a blockchain bring over what came before. But I'm also going to kind of race through it a little, and these are going to be sort of text-dense slides. And I am going to have citations in the corner where you can kind of go to look for more info. So, all right. I assume that everybody here has some familiarity with the basic idea of cryptography, where you have originally some secret key that's shared between communicating parties. And you can do things like encrypt a message that by one party that another party can decrypt. You can have one party authenticate a message that the other party can then verify that it's the right message from the right person. And historically, you had to use secret keys that were known to both the sender and the receiver and nobody else. Then we got what I'm calling the first key cryptographic innovation that led to all this blockchain stuff, which is public key cryptography. Can we do cryptography over the public internet? Can we do cryptography without having to sort of meet face-to-face to exchange our secret keys? And there was some classified stuff that I'm not going to talk about. But it all sort of started with Diffie and Hellman, who invented a protocol for using a non-secret channel. So a channel where you're sure you're getting the right message, but everyone else can see it too. And it's an interactive protocol for two parties to agree on a secret key that they can use to do other stuff. Then you've probably all heard of RSA. That was the first sort of what you might think of as modern public key cryptography, where you can encrypt with a public key, decrypt with a private key. You can sign with a private key and verify with a public key. And this is sort of key for everything we're building, because blockchains are all about transactions, and transactions are all about some public key signing an object that transfers ownership of something to some other public key. And then elliptic curve cryptography is almost a footnote here, because it doesn't change any of the fundamental stuff that you can do. What it changes is it makes everything a little bit more compact and a little bit faster, which is going to be important, because what happens on a blockchain is everybody in the world who participates in the system is going to have to store every bit of data in the whole system, and is going to have to verify every signature in the whole system. And so the smaller and the faster you can make it, the happier we are. So public key cryptography, first key enabling technology. So the second one is cryptographic hashes and cool stuff we can build with cryptographic hashes. And so the sort of key question I put up here is, can we summarize a large chunk of data in a small amount of space in a way that we can be sure that we can see it again later and be sure it's the same? And there's a bunch of other important properties that I'm kind of hand waving over. But that's the basic idea, is we're taking a large amount of data, making a very small summary, and the summary is secure, can't be forged. And so the super cool thing that we can do with this primitive, that again is going to be really important to the idea of a blockchain, we have from Merkle in 1979 the idea of a hash tree, which we now pretty much all call a Merkle tree. And you can generalize that to the idea of a hash-based data structure. And a great example of this that probably a lot of you have worked with is a Git repository. So the idea of a hash-based data structure is, you say, I have this function that takes a bunch of data and compacts it down into like a little summary. Then what I can do is take more data and some of these summaries, and I can hash that again, compact it down into a summary of summaries. And you can see how immediately that turns into a tree structure, where one hash at the root can summarize sort of an arbitrary amount of structured data for you. And so in a Git repository, you have your commit IDs, and a commit, a full long commit ID in Git is a hash of a commit object, which in turn has the hashes inside it of its parent commits that it's derived from, and also has the hash of a directory, which in turn contains the hash of some files. And so you've built up this verifiable structure where at the top you have an ID that's just one hash that summarizes everything below it. And this is why if you have a git commit ID, that is enough to prove that you have a correct copy of everything in the repository. And so that's how Git uses hash-based data structures. And the blockchain is another hash-based data structure, where the idea is you have transactions that have IDs that are hashes. A transaction spends from another transaction and references it by its ID, which is a hash. A block gathers together a bunch of transactions, and each block refers to a previous block by a hash. And that aspect where a block refers to a previous block by a hash, that's what makes it a chain. So hash-based data structures, super cool. A blockchain is one, but there's sort of other ways you can use them too, and we're still kind of learning about all the cool stuff you do with them. And then Adam Back, Hashcash, was the original proof of work, or I guess there was various work in this space, but it's sort of the popular one that everybody's heard of. And the idea of proof of work is you can provide someone with a hash that has certain restricted properties, like you treat the hash as a number, the number is larger than a certain value. The higher the value, the harder it is to get a hash that has that property, because what we assume is, well, if you want a hash that's greater than a certain number, the only way we know how to do that is hash some data. If it doesn't work, pick some different data, hash that, keep trying over and over and over. And so by the time I give you a hash that is that has some restricted property, that is in some restricted part of the space, you know that I've done a whole bunch of computational work to get there. I've spent a whole bunch of energy, and there's no easier way to do that. So that's the idea of proof of work through hashing, is I give you some hash that has some property that I could only have generated by just doing a bunch of hashes over and over and over. And we're going to see that appear again for sure. Okay, so Bitcoin's predecessors, digital currency. You have Chom's DigiCash, which is centralized but untraceable because it uses cryptographic blind signatures, so that the central server, which is the only party that can mint money and the only party that can enable a transfer of money, can do that without knowing who the money came from. And then you have B-Money, which is like the sort of last thing that came right before Bitcoin. Has almost all the, has a lot of the stuff that we'll see again in Bitcoin. It has Hashcash-like proof of work. It has transactions that are signed with public keys to transfer something from one party to another. It actually has contracts in it, but they're not smart contracts. They're just human arbitrated contracts. And everyone tracks everyone's accounts. But what you don't have is you don't have a blockchain. The accounts are just, they're just integers. And then there's some other stuff I threw in here that's just like, well, these are digital currency, but they were centralized and they're dead now because the US government killed them. Okay, so Bitcoin has some stuff that's not new, also has some stuff that's new. So in addition to using proof of work to mint money, which we just saw one slide ago with B-Money, it also uses proof of work mining to settle this question of what order did the transactions come in? Who was first? And this is where the blockchain comes in, because what the miners do is they assemble transactions into blocks. They compete to be the first one to come up with a sufficiently sort of powerful proof of work to add the block to the chain. Another thing that is new in Bitcoin relative to what came before it is a scripting language. So the keys that own the money in Bitcoin are not just like elliptic curve crypto keys. They're little scripts in a little programming language, the Bitcoin script language, that's a lot like Forth, if you're familiar with that. It's a very simple stack-based language. And the fact that it's simple is important in Bitcoin, but did not always get replicated in future projects, sometimes to their detriment, and that will come up. And then, of course, we have the blockchain itself, which is just a data structure. It is a durable, hash-structured record of a history of transactions. And that's sort of, it's the title element of the talk, but you can kind of see what it really is. What people mean when they say blockchain is there's this whole agglomeration of a bunch of different cool technologies. Some of them have existed since the 70s or the 80s, and some of them are more recent, and some of them are specific to Bitcoin itself. And so a lot of the hype where people say, let's use a blockchain for this, it's like, okay, what we need to do is break out of all these technologies, which ones do you need? All right, so this is the part where your blockchain sucks. So I decided, all right, if I'm gonna give a talk about good and bad ideas in the blockchain space, I need a rating scale. So my rating scale is from 1 to 4 blocks. You don't want to be this one. Okay, so when I said I wasn't going to name names, I lied a little bit. But let's be clear, this is the cutest slide in the entire deck, so I couldn't resist. And you maybe have some sense where I'm going with this, but I might surprise you. So let's talk about CryptoKitties. Some of you may have seen this before. It's a project that exists on the Ethereum blockchain, whereby you can own and trade and breed these adorable digital cats. And of course, there is one big strike against this project, which is that it is totally pointless. Why do you want to own and trade and breed adorable digital cats? Well, they're cute. That's pretty much all they got going for them. So what kind of properties do the digital cats have that makes them appropriate or not appropriate for a blockchain? And actually, for the most part, they do pretty well on this scale. So they're unique objects with ownership being traded in a decentralized system, right? There's no central database that records who has which cat. And it's to everybody's advantage that that's true, right? So nobody can sort of shut off your ability to trade or breed your digital cats, in theory, if it's all implemented right. And it's using smart contracts, right? It's using this cool scripting stuff that we talked about. Because it's on Ethereum, it has a much fancier scripting language than the Bitcoin language. It does a lot more stuff, which is good and bad. And in fact, one of the strikes I would say against CryptoKitties is I think it is a little bit of a misuse of smart contracts, because I don't know if any of you were kind of closely following the space at the time. It overwhelmed the Ethereum network a little bit. Everybody was like trading and breeding these cats, and the process kind of brought Ethereum to its knees for a while. And this is sort of a big lesson about good and bad ways to use sort of blockchain scripting. And this is something that'll come back up later. The last big strike against CryptoKitties, and this is fixable, but I'm kind of mad about it. The thing that CryptoKitties have on a blockchain is they have DNA, right? They have this little string of bits that kind of describes how their appearance is generated. And when you breed them, they do some kind of evolutionary thing where they mix up their DNA bits somehow, and then you get a new set of DNA bits that's a new cat. The part of this that's not on the blockchain is the pictures. The pictures are generated by a centralized service that if it went down, the cats would still exist in principle, but they would not be cute anymore. And like their whole point of existence is to be cute, right? Like what makes one ridiculous digital cat more valuable than another? It's because like you think it's cute. So if some centralized third party can like say, okay, well this string of DNA is now going to be cuter and this one we're going to nerf, like, well, come on, that really defeats. So like, you're so close, you're so close. 2.5, maybe. I gave it a 3. 3 blocks. Like, okay, it's kind of pointless, but if you remove that for a second, actually we're really illustrating a lot of kind of the cool aspects of things that you can do with a blockchain. All right. So next, here is something that everybody wants to do. The first time they hear about a blockchain, they're like, ooh, okay, we've got this global distributed network of stuff. And I can just make a transaction, and then that transaction will be in the cloud, in the blockchain, and then I can get it back later. I kind of gave away the answer here. No. So the problem with this is the way the blockchain works is everybody who's participating in the network has a full copy of all of it, right? That's why you can put a transaction into it and get it back later. It's because someone else is paying the cost of storing a copy of it on like every computer in the universe. So don't do this. The blockchain is good for storing like crucial transaction data. It's good for storing like tiny summaries. Remember hash trees and hash data structures? The blockchain is great for storing like the hash of a whole bunch of complicated stuff so you can prove things. So you can like prove that you knew this data at a particular time. Don't store your data in the blockchain. No, very bad. Now, I don't have any concrete examples of this to show you, and the reason for that is there's a lot of projects that somehow involve storage and somehow involve a blockchain. Generally speaking, they don't actually store the data on the blockchain. The ones that did that are already dead. Yeah, so the way that you should do this, if you want to do this, is you build your own system for storing the data, and then you use the blockchain to do accounting, to track the ownership of the data, to store sort of, hashes to prove that the data hasn't changed, to store metadata. Don't use the blockchain to store your data. Like, well, yeah. So CryptoKitties, right? You're storing a DNA, right? You're storing the smallest possible summary of the cat, and there's sort of. I was right. So I was complaining that the cat images are done separately. And the thing that you want to do here is not store the cat images in the blockchain. Don't do that. You're right. The thing that you want to do is like make the process of generating a cat image from cat DNA be some deterministic function that everybody knows. And then you can like take the hash of that function in whatever your favorite language is, because that code's not running on the blockchain, right? You can do it in Python, JavaScript, whatever you want. Like store the hash of that function somewhere in the blockchain. And then you know that you're getting the right cat. So yes, a hybrid approach is what all the actual blockchain file storage projects are doing, as far as I know. So, like, okay, if you're smart about it, as long as you're smart about it, don't store data in the blockchain. I don't want to get myself in trouble. I don't want the takeaway from this to be that like all these projects are bad, because as far as I know, all the actual projects out there are doing this right. So this is one I sort of picked because I've heard it come up a few times recently, and like most of what I'm doing in my slides here is trolling. But this is sort of a real one, right? This is one of the ones where you kind of it keeps coming up over and over, and it's well, anyway. Let's look at like how is this exactly? How do we do? So you've got real physical stuff, right? You're tracking the movement of real physical stuff from place to place. This does not fit the blockchain well, because you are always going to have the problem that like the real physical stuff might not be in the same place that the data says it is. And the blockchain only works with data. It doesn't work with stuff. The stuff lives in the real world. So there's like things you can do, but there's always going to be this sort of mismatch. But what are we doing when we do this kind of logistics that when we're tracking this stuff? Well, we're dealing with multiple different independent companies, okay, separate entities. So there's no obvious single party to host a database. Because usually the alternative to a blockchain is like, well, what if we just put it in a database? So, okay, we passed that test. There's no single central party that wants to host the database. And the parties that are dealing with this stuff, right, their databases that they use internally are probably like from the 70s, they're in COBOL or something, who knows. They don't want to try to sync them up. And they don't want to do anything at all to them, right? They want to leave them alone. It would be non-trivial for them to sync their databases up, like, oh, let's put a web API on it. And so we're in addition to this, we're dealing with stuff that wants to be like audited, logged, tracked, right? We want to be able to go back later and say, okay, this contaminated item, right? Who did I get this from? How was it shipped? Where was it sourced? Where was it supplied from? This is great. This is like blockchain. This is a great sort of blockchain fodder, right? We need a permanent audit trail stored durably by everyone forever. That's sort of what blockchain is for, right? Oh, there, I did it. I used blockchain as a mass noun. I knew I was going to. It just slips in. And I guess another thing that makes this work, right, is everybody sort of expects up front that everything's going to go smoothly. And it's only after somebody fucks it all up that you're like, okay, let's go back and look at the log. And that's where you say, this is a perfect match for a system where the log is provable, right? All you need is one hash of the latest block, and this proves the entire contents of all the history, and everybody has a copy. So that actually feels like it matches pretty well. And another thing that I see coming up behind the scenes a lot in this kind of project when people talk to me about it, that I think maybe makes a big difference in favor of sort of blockchain solutions is, okay, everybody has their own systems. They're all historical. Nobody wants to adapt them to work with anybody else's. If you have some new technology, everybody can just kind of agree, okay, we're going to move to this cool whiz-bang new technology and forget the old stuff, and like don't worry too much about like whose system is going to be adapted to work with whose. So this is a place where hype kind of works in our favor, right? Blockchain has hype. We have some old systems that like really need to be replaced. Well, let's replace them with the thing that has the hype. Could we replace them with a different thing? Yes, but hype sort of helps push it through the business layer. So it's a benefit. So I gave this one 3 blocks. There's like a lot of ways this can go wrong, but like I feel like it has a lot of potential. I feel like this is one of the things where maybe all this blockchain buzzword is going to make sense. Okay, this is another one I sort of gave away in the bullet points. So people, much like with storage, right? Sometimes people look at the blockchain and they go, aha, right? We're running scripts in the blockchain, in the cloud, right? In somewhere that's not my computer. So I don't have to deal with like, where is it going to run? It runs in the blockchain. Well, no. In the blockchain means that it runs in a duplicate copy on the computer of every single person who's participating in the whole system. So you have avoided figuring out where to run a copy by forcing everyone in the world to run a copy. And this gets back to the CryptoKitties stuff, right? Like, why is it a bad idea to use blockchain scripts to like take apart cat DNA and generate random numbers and like mix it up and process it together into new cat DNA? Because you're making every computer in the whole system do all that work. And in the case of the CryptoKitties, it's like maybe not so bad, but I feel like the fancier you make your scripting language, the more you are tempting people to go, it is a magic computer that runs code somewhere else that I don't have to think about. And so you're inviting them to do this thing where they're like, oh, I'll just put all the code into my smart contracts, and then it runs on everybody's machine. It sort of invites people to put costs on other people. So don't do that either. And this is where I'm going to take a little tangent to talk about, well, okay, if that's bad, what do you do instead? And the thing that you do instead is you have the people involved in the transaction agree offline to whatever they're going to agree to. They do a bunch of pre-computation offline. They generate a proof that their computation was done correctly. They put that proof and just the code to check the proof on the blockchain. And this is what you see when you look at how Bitcoin works, right? You do the work to generate a new public-private key pair, a public key and address for me to send funds to. I do the work of building a transaction, finding some coins in my wallet that I want to send to you, signing the whole thing. The only computation that's done on the blockchain is checking the signature. That's it. So anytime you see an idea where it's like, I know what we're going to do. We're going to do a bunch of computation on the blockchain. Just say no. Do your computation offline in some other system. Generate a proof. Check the proof with the script on the blockchain. That is the right way to do blockchain scripting. Okay, rant over. All right. So last but not least, let's talk about one extremely popular blockchain use case that just keeps coming up over and over. And I guarantee, like, you have all seen this one. You don't know it yet, but this is like the one that you're probably all most familiar with, whether or not you're in the space yourself. This is a really wildly popular blockchain application. And as far as naming names goes, other than Ponzi Coin, which is its own thing, I have only included projects on this slide that have already taken the money and run. And if there's like name confusion or you see something on here that shouldn't be, oops, let me know. But as far as I know, every project on this slide already took the money and ran. So I feel okay mentioning their names and using their logos, which I just grabbed from Google Images. And I'm not even including the ones that were like shut down by the SEC. It's like, that's arguable, right? It's like, oh, well, maybe we were doing something good and the government took us out. But these are just the ones who took the money and ran. So this one seems pretty obvious, right? Like, come on. But what was that? Well, right. So they accomplish their goals, right? Like, if your goal is to run a scam and take everybody's money, then like it seems like the blockchain has actually done pretty well for you. So I am actually going to award this one some counterfeit blocks. All right. So what have we talked about today? We talked about enabling technologies that go into Bitcoin and the blockchain. In particular, we talked a lot about kind of a brief history of cool cryptographic innovations. We talked about Bitcoin, and I gave you a sort of an overview of a few use cases for the blockchain that I think are better or worse, and a little as to why. So I hope that what you took away from this talk is that blockchains are really cool technology. They are not purely hype. There's neat stuff you can do, but it's really non-obvious in a lot of cases. And so if you just kind of look at it and go, I have a blockchain, excuse me, I have some blockchain and I want to slap it on a project, probably you will not go very far, but there are still a lot of good things you can do if you know where to look for them. So now I'm gonna open it up for questions. So ground rules for questions. Number one, your question must be in the form of a question. Number two, please use the microphones. And number three, please, I know there is a lot of politics in this space. When I mentioned the name of my employer, I heard a couple of chuckles. Let's try to stay away from that. I am happy to talk about that some other time out in the hallway. So go ahead.
Regarding not using the blockchain as a distributed storage mechanism, I was reading some articles talking about people storing illicit or contraband content. How do you avoid that? Because that kind of ruins it for everyone, why we can't have nice things.
Yeah, I think there are steps you can take so that, against people storing contraband content in the blockchain. There are steps you can take, and some of them are technical and some of them are legal, right? And the legal ones involve, the government or the courts hopefully recognizing that there is value in this system and there's value in it working the way that it does. And so that it doesn't make sense to penalize people for kind of possessing something not by their choice and sort of in the course of doing something else. Will it work out that way? It seems like it hasn't really come up much yet, right? Like I have been told that there is, child pornography in the blockchain, but it's encoded in such a way that it's like not immediately obvious. Kind of, it's not there if you just go looking for it. There is a clever trick that I think Bitcoin has started doing, or if not, is at least planned, which is for every machine that is running a copy of Bitcoin, what you can do is like generate a key, right? And then just sort of do a trivial obfuscation, not even encryption, of the files on disk with that key. And that means that like the bits on your disk, whatever crap is in the blockchain, the bits on your disk don't contain that crap. And this prevents a kind of trolling where somebody like puts antivirus signatures in the blockchain and then has your antivirus delete it, which has happened. Next question.
So I'm going to try and coin a term really quickly here to help me frame my question, which is the long white beard of the blockchain. As I understand blockchain technologies, every blockchain grows a long white beard, where as time goes by, the blockchain just gets longer and longer and longer. And everybody involved in this project needs to hold on to the entire long white beard forever. To what degree does the length, the eternal length of the long white beard factor into how bad of an idea a particular blockchain technology is?
So Ed, did you just come up with that, the long white beard?
Yeah.
That's actually very clever. I'm going to use that.
Hey!
Yeah, so this is definitely something that comes up, and the long white beard factor is a big part of why it's bad to store data in the blockchain, right? Oh, and I'm going to use this now. This is great. I love this. I'm going to take this back to work, and we're going to start using this. Yeah, this is a key factor in why it is bad to store a bunch of crap in the blockchain, because everybody has to keep a copy of it forever. There are ways around this too. For Bitcoin in particular, the only thing that everybody really needs a copy of is what's called the UTXO set. That's the unspent transaction output set, which is a summary of what are sort of the current balances effectively. You don't really need all the history forever. You just need it long enough to kind of verify it to get to a state of where are we now. Except that if a new participant wants to join the system, they either need a copy of everything forever, or there needs to be some way to sort of cryptographically prove that the summary you're giving them is current. So there's sort of work on that. But then of course the unspent transaction output set itself, that really does need to be kept around forever, because that's sort of our database of who owns what. So if you crap that up, then like there's no excuse for you. Next question.
Okay. So in the 1990s, the web was kind of, many people said it was an overhyped technology and people were using it for things that it really wasn't at the time very suited for. People were saying, oh, every desktop program will make that a web page. And it, kind of sucked at that, like web email programs pretty much sucked. And then Ajax came along and suddenly, well, now actually, yeah, you can do pretty much everything in the web and everybody's doing that. So is there kind of an Ajax that's going to come along for blockchain or something else that, in 10 years, people will be like, well, now blockchain will suddenly be well suited for all these use cases?
Yeah, so I didn't put in a slide for this, but and this is kind of Bitcoin centric, because I admit that sort of I do Bitcoin centric stuff, right? That's really the part of this that is what I focus on. The thing that I'm really excited about now is the Lightning Network. And the idea of the Lightning Network, which I think is a good template to build other stuff on, is kind of like I was saying before, don't do all your work on the blockchain. Do as much work as you can off-chain, which is how we describe it, and then use the blockchain for the thing that it's good for, which is sort of your final permanent binding arbitration and storage of your sort of final decision. And so what you do in Lightning is you use some other fancy cryptography that I definitely can't get into and also mostly don't understand. You have the two parties that want to send microtransactions. They sort of each put a bond into kind of a shared output, a shared account on the chain that is co-owned by both of them and can't be unilaterally spent by either. And then they do a bunch of cryptography off to one side. And what they do is they trade microtransactions back and forth. And as they do this, they generate proofs. They generate like, here is a proof that the current balance is this and this. Here is a proof that the current balance is this and this. And they also sort of ancillary generate proofs that the old proofs are no longer good, right? So I have the proof of the current balance. I also have a proof of the previous balance, but if I try to claim coins using that, you have a proof that it's no longer good. So we're generating this whole string of proofs, and then the only thing we need to do to the blockchain is either submit our mutual agreement as to what the final outcome was, or if one of us cheats, submit a proof that it was cheating. And so this, I think, is like the structure we're going to use for all kinds of future blockchain stuff, is building protocols that only use the blockchain as the sort of mediator of last resort.
Hey, I wanted to know if you have like a guilty pleasure blockchain project, like one that sounds absurd, but you sort of think it might work, but you're sort of ashamed to admit that you think it might work, and so, but you like to think about it?
So work is not a good word for this one, but it's Dogecoin. It's, I work with very serious people who get very mad about like shitty altcoins and blockchains that are doing stupid things that don't need a blockchain, but everybody loves Dogecoin. You can't not love Dogecoin. It's the cute factor. So there you go.
I'm curious where you would rank certificate transparency as a possible use for blockchain with your Lego rubric.
Yeah. So as I understand it, certificate transparency is the idea of sort of whenever a CA generates a certificate, you like kind of timestamp it and hash it and then sort of store that somewhere permanent. So you have a permanent record that a certificate was generated. Yeah. So I think this is a place where like maybe blockchain, the data structure, and it's hard to know at what point to call it a blockchain, right? You take out a certain number of pieces, is it still a blockchain? But the idea of a hash-based data structure where you have a permanent, sort of stored by everyone, auditable summary of transactions that happened in the past that you can go back and look at. Yeah. I think that's.
So blue Lego?
Perfect. Yes, you get 4 Legos.
All right.
So having come from a project where I was doing logistics related database stuff, I'm curious if there's with the logistics and blockchain technology that you could envision, if there's a way you could handle the fact that receiving as well as sending is a really important step in the typical logistics process, and that the accounting that what you sent was then received, that's actually a point of contention.
Yeah. So of course, one thing that a blockchain can't do is like force you to make a transaction that you don't want to make, right? If you fail to tell the blockchain that you received the thing, the point of contention is still there, right? It can't force you. The audit log itself is sort of durable, but it can't force you to log an entry.
Okay.
But it's like totally the case that not every kind of blockchain transaction has to correspond to a human transaction, if that makes sense. So you can totally have like, if you and I are doing a deal of some kind, if I'm sending you some goods, you're sending me some money, whatever, that can be as many transactions on the chain as you want. So yeah, you could have a transaction to log when it was sent, a transaction to log when it was received. You could have like, you could have a transaction sort of like once a day automated from the ship or whatever, saying this container is still on here. If you want to sort of be able to trace like, well, okay, it went missing. Where did it go missing? Right. So there is a lot of flexibility to do stuff like that.
Great, thanks.
what are your thoughts on how to deal with the energy usage problem of blockchain? Bitcoin alone, last time I heard, used as much electricity, as much power as the entire country of Ireland.
Yeah. So I guess one point that I have on this is like, people talk about it as a waste. It is a waste if you're not getting something sufficiently valuable for it. So my kind of take on this is there are a lot of different proposed ways to do consensus. Because that's sort of the original Bitcoin proof of work innovation is like it's a way to do consensus among a bunch of parties who don't trust each other, anonymous people on the internet. And so there's a bunch of proposed ways to do this that don't burn a bunch of energy. Proof of stake was sort of the first. There's been a bunch of stuff since then. And my take on this is like a lot of those have been demonstrated not to work. Many of them have been sort of used for a while, but it's not really clear kind of what their principled reason for working is. The nice thing about proof of work is like if you can sort of draw a bound around the rate at which you turn energy into hashes, all that burned energy is like going to a useful purpose in a sense, which is like proving that the system can't be attacked because somebody would need to spend a lot more energy. So in that sense, if it gets you something you really value and there's no better way to get it, then it's not wasted. But I think it would be really nice if we did come up with another way to do this. I just don't know that I trust any of the ones that exist right now. All right, I think that's it. Thank you very much, everyone.